Technology brings us closer together, even when we're far apart. Google Developer Groups host meetup events for local technologists to connect, learn, and grow with others in their area.
The project I'm mostly proud of would be teaching Introduction to Programming to 7 girls in my hometown.
In the GDJ, I used to attend various workshops, like it was on Firebase, Android, Cloud. Everyone is learning from someone else.
We started to meet twice a week for a long time, learning Google Cloud. Amazing experience.
After joining Accenture as a software engineer, I started to share my journey in Medium, podcasts, and talks at online bootcamps.
My talk inspired one of community members a lot, so I mentored him to start his latter path. And 1 year later, at the same conference, he was giving a talk at the same stage.
One member of our community moved from being a DJ at our event to developing the first leading bank in the country.
When we do events that impact a lot of people, we are bringing opportunity to our region. So a lot of investors, a lot of startups, they will start to see opportunities here.
Hello everyone, good evening and welcome to this section of Community Learning Series. Febe, and I'll be talking to us. Today we have Faithful Paul in our midst and he's going to share with us his knowledge on data structures. Fruitful is skilled and result-oriented software developer with more than half a decade of experience working in a variety of environments with a breadth of programs and technologies. And here he'll be sharing his knowledge on data structures. He has a lot of experience in the software development field, and he's here to share this experience with us. Data structures can be used to store and organize data. Learning data structures and algorithms allows us to write efficient and optimized computer programs. So let's listen to Fruitful share his knowledge in this field, and keep your pen and your books together so that you can jot something and learn a lot from this series. Fruitful, are you there?
Yes, I'm here.
All right, so I'll be handing the stage to you. Go ahead and share your knowledge.
Okay, thank you everyone for making it to this section today. It's really an honor to speak here and share my knowledge of data structures with you. So before I start explaining data structure, the concept of data structure, I'd like to tell a brief story. Now, this is related to my experience with data structures. So some time ago, I was taking an interview at a company for a certain front-end developer position. So before this interview, I was very, 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 very confident I'm going to ace this interview. I'm going to pass this interview. So what I was expecting to see in that interview, or what I was expecting as the questions I was supposed to get, I was expecting things on CSS, React.js, and things related to front-end development. So the first question I saw when I opened that interview was a question on linked list. When I saw that word, the linked list, like I was very confused then, because I didn't even understand what a linked list is, and that was my first time of seeing it. So to cut the story short, I ended up failing the interview. I ended up failing woefully. Like I didn't just fail it, I failed it woefully. And that was because of my lack of knowledge in that aspect of data structures. Even before then, I took other interviews, like I've taken other interviews before that particular interview, but they didn't ask me any question related to data structures or even algorithms. So I didn't deem it that important in the job market. But so that interview was something else. So the question of data structures and algorithms appearing in in your coding interview is a probability. It depends on the company's interview process. Different companies have different interview processes, but mostly in companies in Nigeria, though some of them have started changing that. Most companies in Nigeria don't ask questions concerning data structures and algorithms. But if you want to get jobs in the big tech companies and Fortune 500 companies, you should have these concepts and these principles in your head. You should know how to use data structures. You should have an understanding of data structures. You should have an understanding of algorithms. Then you should also have an understanding of system design and architecture. So this all these are just concepts that you should have to be able to ace any coding interview. So before I dive into what coding and what data structures are, I'd like us to break out from this mindset of data structures being complicated. There's a reason why most companies leave this tag in their job descriptions. Having a bachelor's degree in computer science is preferred. Why most of them leave that in their job descriptions is because they believe that anyone who passed through university and have a knowledge of computer science is going to have a knowledge of most of these concepts, and they don't really need to come and reteach that person those concepts because they believe the person already has it. And that's why you see most people with computer science degrees easily get jobs because they have that knowledge to pass the interview. Maybe they don't have field experience, they don't have field knowledge, just like a mechanical engineer and a road mechanic. Most companies would rather employ the guy that learns mechanical engineering in university than employing the mechanic, and that still works even in the tech world. So if you want to prove and show your competency to most companies, you should be able to prove that you know some of these concepts because they use some of them as check marks and for assessments, so for potential employees. So let's jump into what data structures are. So data structures, before we look deeper into what data structures are, we have to understand that the world we live in today, both the digital and the physical world, revolves around data. There is nothing that we can do without data. In our day-to-day life, we see data used on daily basis. Every aspect of our life is revolving around data. So data is even one of the strongest foundations of humanity. So data can't be used unless it's structured and organized. Until data is structured and organized, it can be manipulated or it can be processed. And that's where data structures play a very important role. So, what data structures are? Data structures are containers for storing, organizing, and processing data. Even without even hearing about even data structures for the first time, you implement data structures in your coding projects like arrays. Sometimes we store data in arrays in most of our coding projects, and we tend to use them for particular functions and operations. Right there, you're implementing a data structure and you're using data structures. But I don't get it why people are also scared of what they implement and scared of what they use on their day-to-day in their day-to-day life. Maybe it's because of the naming conventions, and maybe it's because of the hype around it. Like most people try to make it complex, And the only thing complex about data structures, as I said in an earlier post last week, was that data structures, the only thing hard about them is their naming conventions. So data structures are etched into the many operations in our universe. And not just even the digital world, even the physical world, like I said earlier, our plates, you can see them as notes to books. Yes, they are forms of data. Even verbs, verbal conversations, yes, they are data. And all these things, if they are not organized, they can't be used and they can't things can't be derived from them. So we'll be looking at the importance of data structures. So data structures have a lot of underlying values and importance, and without data structures, I don't think there will even be any computer, because even computers itself revolve around data structures. Most of our programming languages were built on different data structures. Like Python is stack oriented, even JavaScript too. Some their interpreters and compilers are stack oriented. So to show you the importance of data structure, how it has been etched into the foundation of the digital world, data structures play a very vital role in the job markets too, not just in its implementation and its day-to-day in our day-to-day life. It also plays a very important role in the job market, because many companies, since the rise in many companies using it as assessment, have been on the increase since 2020. So before then, it was more, let's say, it's minor stream, but now it has gone more mainstream. And many companies even have different rounds of coding interview. So you couldn't even face only one. You may face behavioral, system design, data structures, algorithms, and the rest of them. So having data structures as a skill is very important in the job market. It plays a very, very important role in helping you ace a coding interview. But also, acing a coding interview doesn't mean you're getting the job, but is a plus, is a bonus. And also, you not knowing data structures is not going to give you any disadvantage. It's not putting you at any disadvantage, or it's not like a setback as people make it out to be. Though if you are in the job market, it is going to be a setback to you. But if you're this kind of person that is learning coding, for maybe he's just using it for knowledge, or is someone like a doctor that just want to get that knowledge of it and just apply it in his field, data structures may not even draw you back a bit. But it's also important to learn them, because most of these concepts, due to the fact that most people are self-taught and learn through boot camps. So there's this tendency of most boot camps, and you learn your self-taught learning routine, you omitting the data structures, and it's very rampant. Many people, this is even their first time of hearing about data structures. Why? Because it's not really talked about, but the hype around it have been increasing recently, and many people are getting to know about it. But it provides an edge in the job market. And apart from jobs, because most people talk about data structures, they are trying kind of job oriented. Data structures doesn't just work only in the field of jobs. There are many things we need data structures for, even in our projects. The reason why most apps are inefficient is because they didn't implement the right data structures. They implemented data structures because there's no way you're going to build a system without data in it. So there's always a data structure to manage that data. But they implement data structures, but they don't implement the right data structures. And that's where the problem is. So having the knowledge of data structure will also help you to build more scalable applications and more efficient applications. So we're going to be looking at the roadmap for learning data structure. So I just wanted this talk to be very concise and straight to the point, not too buggy, so that it doesn't get too complicated in your head. So I wrote down a roadmap, the same roadmap I used in learning data structures. So while I was learning data structures, then that was around 2021. So finding the resources for data structures was very, very, very hard for me, and even understanding it was very hard for me. So I was just struggling to learn. I took some handouts from university students in computer science, students studying computer science. I took their handout and was reading, trying to understand, asking questions, and the rest of it. And it wasn't an easy journey. So these were the few things. This how was how I learned data structures, and how I made it. I've made up a list that will help newbies out there who are trying to get a hang of data structures so that they can easily learn. And also, I currently started a series explaining data structures in depth using physical and visual depictions to give learners a more mental picture of what data structures are and understand them better. So this is the list. I started with linear data structure. So before I even go deeper into the roadmap, I want us to understand there are two types of data structures. There are linear data structures and there are non-linear data structures. So linear data structures are the ones that appear linearly or in a straight line, something like our arrays, where each of the elements or the collection in the collection of that data structures are side by side. They have a side by side relationship. While non-linear, as the name suggests, it doesn't appear linearly. It's either that the nodes have a parent to sibling relationship, or it's connected with edges, or is cyclic, something like that. So this was the roadmap I used to learn data structure. So I started with arrays. Normally, almost every software developer knows what an array is. Just a data structure is the most common data structures. So the next data structure I learned was stack. Learning this data structure wasn't that hard, but I found out that many people find out that stacks are hard because they can't seem to wrap their head around the concept of stacks. Stacks particularly is even the reason why most compilers exist, and most functions you see on your computer, like the undo redo function you see, is due to is powered by stacks. So stacks, I like using virtual depictions like real life objects to explain data structures, because I believe that there is relativity between the physical world and the digital world. So if I'm explaining these stacks, I'm going to use a real life object. So imagine a collection of books. A reader has a collection of books and they are scattered. So when they are scattered, he finds it hard to single out or pick a particular book he wants to read. So what does he do? He arranges the book together, he stacks them up together on a bookshelf. And that's how stacks are. They are used to stack up a collection of nodes. Nodes simply means elements of a data structure or pieces of data. So the reader stacks those books up in a bookshelf so that he can easily access books. So in the computer world, stacks are just very, very, very similar to arrays. But the thing is that they function on this principle called the LIFO principle. That means last in, first out. So the last book that was put into the shelf is always the first book that is going to be taken out. And that's the same thing that applies in our stack of plates. The last plate put on the stack is likely the last plate to be taken out of the stack. So the next data structure that I learned using this my roadmap was queues. And we see these queues in our day-to-day life, and also queues even play a very important role in system design. Like you have heard of the pub sub architecture and message queue architecture. So the queues play a very important part also in mostly systems. So queues are data structures just like stacks, but unlike the stack, the first in is the first out. So it operates on the principle called FIFO. That means the first in is always the first out. The first person in the bank, the first person to enter a bank queue is the first person to go out. So and that's how it operates. So the next data structure I learned was the linked list data structure. So this was the one I found one of the most complex. I'm not saying that to scare you. You shouldn't be scared because now these things have been simplified. I simplified this particular data structure in my series, the ASIN Decoding Interview series data structures. So this particular data structure took me months to understand. So trying to wrap my head around the linked list data structure. So a linked list is more like an array, but in this particular type of array, each of the nodes has a pointer to the next node. And one thing about this data structure called linked list is that it's very, 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 very vast, and there are many variants of the linked list data structure. So it made it very complex to me, and there wasn't much learning resources on data structures then because many people weren't putting interest in it. Even the people who knew data structure then weren't talking much about it as of then. So I found it very complex to understand because, and especially in the implementation phase, where most of these data structures get hard and get tough is in the implementation stage because many people can't just try to wrap their head around it, and most languages make it hard for you to implement. But some languages make some of these data structures primitive, like Python, JavaScript make arrays and lists primitive. Some other languages make linked lists primitive. I think Java does. So the linked list data structure is just like an array, is a data structure in which each of the nodes have a pointer to the next node. So there are actually four major variants of this data structure. There's the doubly linked list, the singly linked list, which is the basic linked list. Then there's the circular linked list, the doubly circular linked list. So all these variants has their own constraints for implementation. So the next data structure I learned was hash maps. And this hash map is a very, let me not call it complex, but it's like more like a mixed data structure because in implementing it you add different data structures to be able to implement it. And before I forget, I wanted to say something about the linked list, relating it to a physical object. Linked lists look, if you bring them to the real world, they look more like chains. So as you can see, a chain, each of those nodes, or what they call them, forgotten the name of what they call those. Each and every piece on a chain is linked to each other. Each of them have more like, it looks like a next pointer to the next one, the next pointer to the next one. So a chain to function, each of them are tied together. That means each of the nodes on the chain have a pointer to the other. So you can use that as a visual picture for linked lists. And also linked lists are what powers most of our music players. What enables you to press next music, previous music. That is powered by a linked list. And also in text editors, the undo and redo feature. Some text editors use linked list to implement that. So because each version of that text is going to be stored in a linked list. So when you want to revert to the previous version, you press revert, and that calls the previous function in the linked list. So next, the hash maps. I was talking about the hash map being a mixture of many data structures. There are different implementations of the hash maps, and um, hash maps have a lot of theories surrounding it. So a hash map is, let's say for instance, you created an array. Hash maps were actually arrays, but an advanced form of arrays. So for in an array, if you put 10 items inside an array, there you access them through indexes. And when a new item is added into an array, is assigned a new index. And the index is always going to be the length of the current length of the array at the moment. So minus one, because it starts from zero. So hash maps, and due to that fact that each nodes are added into the array, and it takes and it's making the array get longer and longer and longer and longer, and so big, and it's the time complexity of finding particular nodes, individual nodes from an array, is very long. So someone came up with the concept of hash maps, using when a new node is added into an array, you hash it, and you find the hash of it using a hash function, and give it something like an index based on its hash. So it's going to be something like, if the array, you just want it to be of a size of let's say five indexes. So what is going to happen is that when a number is about to be added into that hash map, you're going to run a modulus operation, that's finding the remainder. So if the number is 10 and the size is 5, and you're going to run the modulus operation on it, and you find that there's no remainder, that means the remainder is 0. So that number 10 you wanted to add into the hash map is going to be given the index of 0, because of the remainder is 0. So this hash map is very fast, and it has a very fast time complexity in getting individual nodes, and that's why it's widely used. But it came along with its own problems, and that's why it had what they call collision theorems. So they created theorems that try to solve this collision, because 10 10 10 modulus 5 is going to give you 0. That means you're giving 10 the index of 0. And then 15 modulus, if you wanted to add 15 into the hash map, 15 modulus 5 is also going to give you 0. And you're going to still add it into, give it that index of 0. So if you're going to give two nodes the same index, it's going to be a problem when a user like tries to access those nodes, because two nodes can't share the same index. So that's what causes that collision. So collision theorems were developed to prevent that from happening, and that's where other data structures came into play. So there are different methods of solving those collisions. One was the bucket method, one was the beam method, and one was using linked lists. So what linked lists, when there's an existing node at a particular index, like the scenario of 15 and 10, so a linked list is created immediately at that index. The linked list is created and assigned that index in the hash map, and those two nodes will be put inside it. So when you're trying to access 10, you get that linked list from that index, and scan through it, traverse through it, so you get 10. So that was one of the methods that they used to solve this collision. So the next data structures I learned, that now this is under the nonlinear data structures, was the trees data structures. Trees, and you've probably seen this if you know HTML, the document object model. So HTML is one markup language that implements these data structures. So trees, just like in real life, how trees are data structures where each of the nodes has a more of like a family relationship. So nodes can have parents, nodes can have siblings, and node without any child is called a leaf node. And this data structure called tree is very, 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 very vast, and get other entirely different data structures. We can have like the binary search trees, we have the AVL trees, the B plus trees, the B trees, different trees that spawned out from this data structure. So when you're going to be learning this data structure, you've got to take your time and learn each and every one of its variants. Though not all these variants are important, but I don't believe that any knowledge is a waste. Having that knowledge is going to help you, it's going to be beneficial to you later in life or in any of your projects, because no knowledge is a waste. So the next data structure is the heap data structure. So these heaps, it's also like a variant of trees, but the thing about it is that is a little bit more diverse than trees. It's If you look at it from a base perspective, it looks more like an array, but unlike the array, each of its node in it has children and has siblings, though it's implemented in an array format, but it's still a tree. The next nonlinear data structure that I learned that was important and vital to me in coding interviews was graphs. I don't think there's any coding interview that has to do with data structures and algorithms that a question on graph will not come out. Graphs are one of the easiest data structures to learn, though they look very hard because of their theorems, but they are easy, very easy. There are two types of graph. There's the directed and the undirected graphs. And graphs are data structures in which the nodes are connected through what they call edges. So their relationships is, you can look at it like more like a tree without that family relationship. So you can see it as a network, just like your Facebook friends network. Yes, I think that's it. That feature of Facebook is powered by graphs. You see that connection. So the connection between two nodes is called an edge, and graphs nodes in graphs are called vertices. So this is like the basic data structures you need to learn to be able to ace a coding interview and to be able to do well in data structures and algorithms at large. There are many more data structures, and also you can create your own data structure because remember, it's just a method of organizing data and a method of manipulating. I say manipulating. It's a method of storing data. So you can create your own data structure. It just depends on the use case. Even the fact that many of us even create our own data structures, because depending on the project we are working on, we may want to solve a particular problem. So we store data in a entirely new format that is not conventional. There, you just created your own data structure. So there's nothing hard about data structures. There's nothing hard at all about it. It's just that we have this mindset that is too theoretical. Yes, I can agree to that. Data structures is too theoretical because you allow it to be theoretical. You can also make it practical if you implement it on your day-to-day project. And I think that's the best way to learn data structures, implementing them in your projects. So this is all for the understanding data structures, improving your technical skills session. So I believe that by now you should be able to understand, you should have gotten a wide picture and a clear picture of what data structures are and how they function and their complexities. They're not really complex. And don't let anyone discourage you about them and tell you how theoretical they are. They are important. They play a very important part of the computer world. And also, when learning data structures, it's advisable to practice Leet Code. Leet Code is a code challenge platforms for preparing yourself for interview. So when you learn a data structure, you just search for a problem pertaining to that data structure on Leet Code and practice with it. Yeah, with doing that consistently will help you to be prepared for any form of coding interview. So this is all for the understanding data structures section. So thank you.
That was fully packed. Thank you, Fruitful, for sharing that knowledge with us. And I believe we've all learned a lot. Personally, I have, starting from the importance down to the roadmap, and it is so detailed. I have learned so much from this section. Thank you very much for sharing this with us. Um, the next thing for us to do is answer some question relating to this. So I have some questions here um, that I'm going to share with us. So after learning this, can you tell us how to solve these data structures and algorithm questions, maybe a practical approach to solving some of these problems?
Okay, I got asked this question a lot. So solving data structures questions pertaining to algorithms, code challenges, and the rest of them, solving them. The first way to do it is just take a deep breath. That's what I do. Just take a deep breath, because if you try to start reasoning those questions, like just taking them verbatim without breaking them down, you get confused and you may feel that you're incompetent. So first, take a deep breath. That's the first approach. Then secondly, you try to find a base case. There's a base case for every code challenge out there. So try to break that problem down to a base case. Try to find the base case of the problem. Let's say that you are told to traverse a a tree and and collect a particular node from that tree. First, you have to understand a single what a single node from a tree looks like. And when you understand what a single node from a tree look like, you can be able to develop an algorithm to easily search for that. So first, know what you're looking for, and that's by taking a deep breath and taking that question, the question that was thrown at you, and breaking them down into sub problems. Yes, breaking them down into sub problems. And where you find this thing most efficient is in recursive coding interviews. Like most coding interviews that have to do with recursion. Recursion is one scary, very scary what they call coding algorithm. Recursion algorithms that have to do with recursion are kind of hard. Why? Because people find it hard finding base cases of coding challenges, and it looks scary at first. But when you take a deep breath, find the base case and break it into sub problems, you'll be able to easily solve the coding challenge or the coding problem. So that's just the method of that's the method I personally use to solve coding problems. I break them down into sub problems and I try to find the base case of the problem.
Hello, Fruitful, can you hear me?
Yes, I can.
Oh, okay. I don't know. Something happened with my network there. Okay, thank you for giving that explanation to the answer. Um, the next question I want to ask is, how do we know we are ready? Because, okay, as a software developer, I start learning data structure. How do I know I'm ready, right, to take up this text? How do I know I'm ready to start applying to positions that has data structures as a requirement? How will I know that I'm ready for this?
Like most people say that learning is a continuous phase or something like that, but there is an amount of knowledge that you should acquire to be able to apply for those. But it's also advisable to even apply, even though you feel that you're not competent enough, because if you keep on getting if you keep on getting interviews and you keep on failing at interviews, you grow a kind of familiarity with interviews, that the next interviews to come you easily ace them. Like I failed a lot of interviews, and those interviews I failed is what built me up and gave me some knowledge, some particular knowledge I needed to pass other interviews that I passed later. So how do you know that you are ready for jobs, big tech jobs, pertaining that are going to likely ask you questions on system design and algorithms and code challenges and the rest of them? The simple way to know that is understand when you understand these concepts, then you're ready for it. Like if you know, you must not have copy you must not cram code snippets. Like that's what many developers do. They cram code snippets and they cram it in their head and they tend to forget it. And many people repeat that same mistake in data structures. The best way to learn data structures is just understanding the principle for implementing a particular data structure. Like if I'm called to implement a linked list, I can implement it in 1,000 ways, but I'll still follow the principles governing linked lists. And that is how it should be for anybody that wants to do well in data structures and wants to be competent enough to solve any algorithm and solve any algorithm, solve any coding problem or code challenge or any coding interview. That person, you should just understand the underlying concepts and the underlying principles, have a strong understanding of it, that even if you're asleep and you're woken up, you can still explain those data structures. And that's why I find the theory aspect of everything very important. Many people neglect the theory aspects. They always want the practical, the one they can see, the one they can see. But it's very important to have the theoretical aspect in you, because when you understand the theoretical part, you can easily practicalize it. So the moment you have this, understand the principle of the aforementioned data structures I mentioned, that you can easily implement them in 1,000 ways. The best way to learn data structures is exercising yourself to implement it in different ways. So if you watch a YouTube tutorial explaining a data structure, try to implement it in a different way than the person who taught you implemented it, but still follow the same principle. So once you get that understanding, once you have those principles inside you, then you can apply for any job and you can still ace those coding interviews, because you understand the principles, you understand the theory. Once you understand the theory, it's very easy to practicalize.
Okay, thank you. I mean, that was a very, very detailed answer. All right. The last question I have here is something from what you said earlier. So you mentioned where we could actually start learning this because, okay, getting this roadmap was difficult. Can you tell us a place um, to get started, like maybe a site to visit when you have a mind that okay, I've gotten to the stage where I want to learn data structure, and just maybe drop a link that the community members can actually visit or something.
Okay, and that I even forgot that I was supposed to drop a link to sites and places where you can learn this, but my problem with most of them is that most sites and most resources out there on data structures, they tend to forget the fact that most people that are learning these things don't even understand some of the basics of software development, coding, and the computer world at large. So I started a series on data structures, oversimplifying it, making it very easy and making it very let's call it seamless to understand, so that even newbies, even if that's your first time of hearing of data structures or that's your first time of seeing data structures, you easily understand it. So I'm going to be dropping a link to that series. Also, another place where you can practice your data structure skill is on LeetCode. I'll also drop a link to that. So let me just drop them right now.
Okay, so why goes ahead to drop the link to that. I'll share it later in the community knowledge of data structures. So that brings us
I think there's something wrong with your network.
end of this series.
Your network was like cracking. I couldn't even get anything from what you said right now. So please, can you just like rephrase?
I'm sorry, my network keeps doing that. That's what I'm going to say because we've come to the end of this.
Yeah, hi, fruitful. Helen's network seemed to be off. So last thing
Okay.
she was trying to say was that she would send the resources that you mentioned. It's the
Okay.
community about the data structure and how to get started with understanding that, and she will share with the community once you're giving it to her. And
Okay.
she also concluded by saying, I think there are no more questions, and she said that that was the end of the conversation today. Have any
Okay.
final words to say or anything at all you wanted to chip in before this section ends?
Okay. Let me just end with this. Traversing through the computer and the digital world may be complex when you look at it from afar, but when you start diving deeper and deeper into it, things just start to get easy. So if this is your first time hearing about data structures and you're feeling scared of it, or you're feeling um, that this is so complex, let me just tell you, it isn't complex. It's just the naming conventions. So just like, let's just call it big grammar. That's what data structures are all about. But when you start learning them, they get easier. So I just believe that you just take the leap of faith and start learning data structures and find out how easy they are and how interesting they are. So I pray that your journey into the tech world is going to be a blissful one. And thank you for making it to this session today.
All right, thank you very much, Fruitful, for your time. And thank everyone for joining. Helen, last thing about.
Yeah, thank you, Fruitful. Thank you, community members. I'm sorry about the little the thing that just happened. My network was disturbing. So we've come to the end of the series. Thank you for tuning into the community learning series with GDG ABBA. This is where we share tips on how to become a very good developer. We want our community members to be broad, to be grounded in every aspect of their career, and we're here to help in every way that we can. Thank you very much. Till our next episode. Take care.